Greetings to you all! I got my hands on this sad-looking Denon PMA-720AE integrated amplifier. It definitely looks like no one was looking after it. As I always do, I will tear it down till the last screw so you can see what's inside of it, how it's built, and I will give it a good clean as a bonus. Watch this video till the end to see the final result. Great! Just before I start, I'd like to encourage you to subscribe to BoardTech channel. Follow me on Instagram or even consider supporting future videos on Patreon. You will find all the links in the description down below. I will start by removing the top cover, which is fixed with 9 screws. I'm simply using dishwashing fluid and warm water to clean all non-electronic parts. I believe this simple method gives you a great result. Next, I will remove the main slit, which is held by this gland. Luckily, it is not hardwired to the board. Denon PMA-720AE is not a very expensive amplifier, but it is well built and will definitely look better without the dust. Now I will cut all the cable ties, because I will need to disconnect every single cable in this unit. Great, that's done. It's time to remove the first part, which is this tiny remote control PCB. 2 screws are out and PCB is extracted. I will use 99% pure IPA and simple cotton buds to clean it. You will see the process a bit later when I get to the bigger boards. Okay, nothing is stopping me from removing the rear panel. 15 screws are undone and the rear panel can head towards my kitchen sink. Here we are, nice and clean, looking almost as new. I think the power PCB can be extracted next. While trying not to disturb this thick layer of dust, I will untangle the cables, disconnect the power switch PCB, the transformer feed, and standby power feed for the front PCB. 2 screws are out and I can start the cleaning process. I will use a compressed air duster to get rid of most of the dust. I will manually clean what is left using cotton buds and IPA. Great, at least now I can see what we have on this board. There are 3 power outlets for connecting your CD player or other equipment which doesn't require a lot of current. 1 main fuse and the fuse for the outlets. Relay. And a little transformer which provides standby power for this unit. I will move on and remove the main transformer next. Before unscrewing the transformer itself, I have to disconnect this 14-volt supply which feeds the functional part of the amplifier, including the microcontroller. Now the main 32-volt feed. Finally, I can undo 4 screws and extract the transformer. Here we are, that's the transformer after I have cleaned it. As I have mentioned before, it has 2 windings, primary 32-volt and secondary 14-volt winding. Next I will remove the front panel. All cables have to be disconnected first. This cable links the headphones outlet on the front panel with the main PCB and also controls the speaker relays. Next cable carries input audio signal into a tone section of the front PCB. After the audio signal leaves the volume section, it returns onto the main PCB through this cable. This cable here links the microcontroller and the input selector PCB. And the last cable links microcontroller and the front PCB. All I have to do now is remove 4 screws at the bottom of the unit and another 2 which secure the front panel at its sides. After a little wiggle, the front panel is removed. First of all, I will pull out all 5 knobs and undo the nuts, which are securing input selector, balance, treble and bass knobs. Volume knob is held in place by these two screws. After I disconnect the cable which links it with the front PCB, the volume board is extracted too. You can see the motor attached at the back of the volume knob. This motor allows the volume of the amplifier to be controlled remotely. After undoing another two screws, I will remove the on and off switch. Next goes the headphones jack. Functional switch PCB is removed next. You can see 6 amber LEDs. Each of them represents one of the amplifier's input and it is lit when that input is selected. 5 screws are undone and the front PCB is now removed. The front panel had some nasty leftovers from some kind of sticker. I have used a product called Sticky Stuff Remover to clean it. After a few minutes and a little bit of effort, the front panel looks squeaky clean. Alright, let's have a look at the front PCB. Here you can see bass, treble and balance knobs, loudness and source direct buttons. By the way, source direct mode allows you to completely bypass the tone and loudness circuitry. JRC2068 is a low-noise dual operational amplifier, which can often be found in Denon and Marantz products. This particular one is dedicated to the tone and loudness circuitry, and it is bypassed when source direct function is active. You can also see an IR receiver and 2 speaker selector buttons. I guess I could start working on the extraction of the main PCB. But first I need to remove this little board, which protects the cables from melting because of the heatsink, which I have to unscrew next. It is fixed to the bottom of the chassis with 3 screws. After I have carefully flipped the unit, I can start undoing screws which are securing the main PCB. All 4 of them. Great, that wasn't very hard. Before I have a good look at the main PCB, let me take off the remaining parts attached to the chassis, including the transformer base and 4 feet. Let me give the chassis a good clean, and here we are. My next step would be to detach the heatsink from the main PCB. I have a feeling that during the manufacturing process these transistors were attached to the heatsink first and soldered to the main board after. As you can see, these 2 huge capacitors are in the way, so I have to use this adjustable spanner to be able to undo the screws. The access to the rest of the transistors is not obstructed, so I am able to use my screwdriver. 2 more screws which are holding these 2 parts together are undone and heatsink is successfully separated. This amplifier can output 50 watts per channel with 8 ohm speakers, so the heatsink is not too big. I guess it is time to properly clean the main PCB. The procedure is standard. Compressed air duster to get rid of the big chunks of dust, and cotton buds with IPA to clean the remaining dirt. It took me about 20 minutes to complete the whole process. Okay, let's see what we have here. This is an input section. Switching between inputs is done by this Sanyo analog function switch. This function switch is handled by microcontroller, which I will show you a bit later. This amplifier is capable of detecting the absence of signal and putting itself into a standby mode. This function is implemented by this signal level detector, which is located on the foil side of the board. Denon PMA-720AE has a phono input, and you can see the phono stage built into the main board. It is a pretty simple phono stage based on this JRC2086 low-noise dual operational amplifier. On the foil side of this PCB there is a Toshiba TLCS870C series 8-bit microcontroller. One of its tasks is analyzing data which is supplied by signal level detector and switching the amplifier into standby mode. It also controls the analog function switch that I have mentioned before. When the amplifier is in standby mode, this microcontroller is still powered by the current provided by that tiny transformer located on the power PCB. This allows the IR sensor and remote control I/O to remain active and respond to the commands. Let's have a look at what else we have here. You can't miss these two Elna 8200 microfarad capacitors. A diode bridge, which is sitting on its own tiny heatsink. Two relays which allow you to activate or inactivate a certain pair of speakers. Main output transistors are this B1383 and D2083 Darlington power transistors. I was a bit amazed when I realized that pre-out is a branched off signal from the main amplifier output. I'm not sure if that's a common solution, but my logic says that pre-out signal should have been taken before being amplified. Or maybe I'm not following something. Please let me know in the comments below if you know why the solution is implemented. While I was filming this board, I spotted these dark spots on the foil side of the PCB. It looks like a pair of these resistors and the capacitor have been operating at a very high temperature for a long period of time. I have tested the amplifier and it works fine, but I still think that these parts have to be replaced. That constant heat yet created another problem. I'm almost sure that as soon as I touch these parts with the soldering iron, the foil track will just perish. So they will have to be reconstructed. Unfortunately, this is a topic for another video. Great, I'm finally done. These are all chassis parts of Denon PMA-720AE, and these are PCBs and other electronic parts. All of them have been meticulously cleaned and are ready to be reassembled. Here we are. I think I have increased the value of this Denon amplifier by just cleaning it. It would almost look as new if it wouldn't have these few scratches on. Have a look at how it looked before and how it looks now. I think this is it for this video. Don't forget to subscribe to BoardTech channel and I'll see you soon. Goodbye!